Okay, I'm going to go over the Unit 6, Section 2 review. Hopefully, if you have any questions about any of the problems, you can, fast forward to whatever problem you have a question about, and the video will be able to help you. We're going to jump in here. So the first question is just evaluating this piecewise function at different x values. And so we're not graphing it, we're just finding what is sort of the y value at all these x values. So when x is 0, what is f of x? Well, we want to use the top one, but that's for x values less than 2. And 0 is less than 2, so I'll plug 0 in, and 2 times 0 cubed is 0. 1 is also less than 2, so I'm going to plug 1 into this top function. 1 cubed is 1, and 2 times 1 is 2. At 2, we're not going to use the top function anymore, because 2 is not less than 2. 2 is greater than or equal to 2 and less than 4. So we're going to use this middle function, and it's just 5. So it's just going to be 5. 3 will also be 5, as 3 is between 2 and 4 as well. 4, not going to use this middle function anymore. 4 is not less than 4. 4 is greater than or equal to 4. So we're going to use this last sort of equation, and I'll plug in 2 times 4 is 8. 8 plus 7 is 15. 5 is also greater than or equal to 4. And 2 times 5 is 10. 10 plus 7 is 17. Okay. Number 2, floor and ceiling. With the floor function, remember you're going to the sort of like the integer below the number. 7.23 would go to 7. And for ceiling, so if the little legs are on top of the ceiling, little legs on bottom is floor. If it's on top, ceiling, you're going to the integer sort of above that number. It's going to be 8. All right. Number 3, the piecewise function, you got the nice table right here. So we got sort of these 3 pieces, x plus 3, 3, and 2x plus 1. And let's see here. For x values less than or equal to 0, I'll do 0, -1, -2. At 0, it's going to be closed because it's less than or equal. And at -2, we're going to have an arrow because it keeps going after -2. That's just all we're graphing. If I plug in, 0 plus 3 is 3, obviously. -1 plus 3 is 2, and -2 plus 3 is 1. Let's go ahead and do this piece as well. So let's see here. This is between 0 and 2. We're going to go ahead and remember, we're still going to include 0, even though 0 is technically not in this piece. We'll do an open circle there, and we'll do 1 and 2 as well. So 0, 1, and 2. 0 will be open, and then 2 will be closed, since it's less than or equal. If I plug in those, it's just going to be 3 for all these. And then the last one, it's x values greater than 2. We're still going to do 2, even though it's just greater than, not greater than or equal. We'll do 2, 3, 4. At 2, it'll be open. At 4, we'll have an arrow as it keeps going. And if I plug in 2, I get 5. If I plug in 3, I get 7. If I plug in 4, I get 9. All right. So we're going to graph this now. We just want to sort of follow our directions. So at 0, 3, we're going to have a closed circle. At -1, 2, and then -2, 1. And we're just going to have a line that sort of keeps going after that with an arrow, since it keeps going down. From 0 to 2, so 0, 3 is going to be open. Oh, we already have that point. So I guess I'll just graph it over it. And then 1, 3, 2, 3 will be closed. Go straight over. And then we're going to pick up over here. And let's see here. 2, 5 will be open. 3, 7, 4, 9. And we're going to do an arrow after that. Okay. Let's see here if I keep going. Number 4, one more of these piecewise functions. Good. I find these tedious. Piece 1 will be 2x. Piece 2 will be x squared. Piece 3 will be -1/2 x plus 5. And let's see here. It's x values less than or equal to 0 for 2x. So I'll do 0, -1, -2. And it's going to be closed at 0 since it's less than or equal. And it'll be an arrow after -2 since it keeps going after -2. And if I plug in 2 times 0 is 0, 2 times -1 is -2, 2 times -2 is -4. All right, for x squared, it's between 0 and 2, so we're going to do 0, 1, 2. And let's see here, at 0, it's going to be open. And if I plug in 0, 0 squared is 0, 1 squared is 1, 2 squared is 4. And this will have a closed point at the end. And then last one, I'm going to choose, it's x squared is greater than 2. We got to do 2. I'm going to do 4 and 6. You can do 3 and 5. It doesn't matter, but this way I'll get nice whole numbers. And it'll be a little prettier. So let's see here. At 2, it's going to be open. And at 6, we're going to have the arrow. Since it keeps going after 6, we're just graphing it to 6. If I plug in -1/2 times 2 plus 5, I think it's going to be 4. 4 times -1/2 plus 5, you should end up with a nice number of 3 and 6. If I plug that in, you're going to get 2. All right, and let's now we just graph it. 0, 0, we're going to have a closed point, and then -1, -2, -2, -4, and we're going to have a little arrow going out at the end of that. 0, 0, open circle. Okay, I'll put it over it. 1, 1, 2, 4. And it's going to be closed. So this is a parabola. This sort of swings up. And then 2, 4, another open circle around the closed point. And then 4, 3, and 6, 2. And if you did the points 3 and 4, you should get sort of the same looking line. That's fine. Okay. Let's talk about absolute value. So we did absolute value as well. The vertex, remember the vertex, you take sort of the number inside with the absolute value and then the number outside that's being added or subtracted. You take the opposite of the number inside, so this will be +3. If there's no number out here, it'll be 0. And then it says slope, but remember this is sort of right side slope. And the right side slope is just the number that's sort of out front. So it's going to be -3. And so what we would do is we would plot our point 3, 0. And the slope on the right side is you're going to start at this vertex. You're going to go, if it's -3, you're going to go down 3 over 1, down 3 over 1, 3 over 1. Draw your line. And then it does the same thing on the other side. You just go the other direction. Or, if I went down here, I'm screwing this up, but it's coming up from this direction if it's going down here. So I'll go down 3, left 1, down 3, left 1. And there we go. On number 6, our vertex here would be 0, +2. So there's no number this time on the inside of the absolute value, so the first number will be 0. Don't do the opposite for the outside number. You just take whatever that is. And our slope is going to be 2. And again, this is the right side slope. And so if I pop my point 0, 2, and then I'm going up 2 over 1, up 2 over 1, up 2 over 1, doing the same thing on the other side, just going the other direction. And there we go. All right. See here, a few more of these. Vertex here would be 0, 2. Slope is -1/3 on the right side. So 0, 2, we're starting at the same vertex, and then we're just going down 1 over 3. Do the same thing on the other side, just go the other direction. All right. And then number 8 would have a vertex of 2, -1. So remember, I'm taking the opposite value of the number inside the absolute value thing. Slope is 3/4, and 2, -1. And the slope is 3/4. So up 3 over 4, up 3 over 4. Same thing on the other side, just go the other direction. And, oh man, whoops. There we go. Hopefully you didn't screw up your 2 points to the left like I did. Get something like that. All right, and then finally our step function graphs. Just take your time with these. Make sure you're looking at, the inequalities. If they have an equal sign underneath, make sure you do a closed dot. If they don't, then it's open. From -3 to 0, we're at the y value of -1. So at -3, we're going to have a closed circle at -1, and at 0, we're going to have an open circle at -1. We have a straight line going over. Then it jumps up to 1 from 0 to 1. closed, open. From 1 to 8, we're going to be at 4. And then from 8 to 9, we're going to be at 6. And we closed at 8 and open at 9. All right, 10 is going to be very similar. From -3 to -1, we're going to be at the y value of 4. It'll be closed at -3. Open at -1. From -1 to 0, we're going to be at 2. 0 to 4, we're going to be at -1. So we're jumping all the way down here. It'll be closed at 0, open at 4. And then from 4 to 7, we'll be at -3. Ooh. Perfect. All right. If I flip over, man, there's way too many of these problems. I'm going to keep doing these, but if you feel like you got the hang of it, I don't feel like you need to keep doing these. But I'll keep doing it for anybody that needs it. So 11, let's see here. From -1 to 2, we're going to be at 3. And it'll be open at -1, closed at 2. From 2 to 4, we're going to be at 5. We're going to be open at 2, closed at 4. From 4 to 9, we're going to be at 8, open. And then from 9 to 12, we're going to be at 10. Okay. And number 12. All right, -4 to -2, we're going to be at 6. Be closed at -4 since it's less than or equal. -2 will be open. From -2 to 1, we're going to be at 4. Closed, open. From 1 to 3, we're going to be at 1. Closed, open. And then from 3 to 6, we're going to be at -2. So, closed, open. Okay. 13 and 14 are a little different. They do have arrows involved. So for all x values less than or equal to -4, we're at the y value of 3. So here's -4. We're going to go up to the y value of 3. We're going to do a closed point. And all values less than that are going to be at 3. So I'm going to do an arrow. From -4 to 2, we're going to be at -1. And this is less than, so we're going to have open circles. So open circle at -1, or at -4 for the y value -1, going all the way out to the x value of 2. And then for all x values greater than 2, we're going to be at -2. Be closed. Coming over. And then last one, no, this one doesn't have any arrows, so it's just annoying the way they did their less than or equal. So let's see here, from -3 to -1, we're at 5. And these are going to be closed circles for both of these. From -1 to 1, we're at 3. It'll be open circles for both of these. I'm doing it again. And then from 1 to 3, we're going to be at 1. It'll be closed for the first one and open for the second. And then for the last one, 3 to 6 is at -2. So closed, open. All right. Please email me if you have any questions, and I will get back to you. Make sure you go on and do your digital assessment of learning, whatever it's called, and have a good day.